come in. Hello.
Miss Amy Burd, so you teach regular physics, AP Physics 1, AP Physics 2, correct?
That's correct, yes.
So can you explain the difference between the three?
Sure. Physics 1 is just kind of a basic high school physics course. It's algebra based. Kids learn both the concepts and the problem solving nature of physics. It covers mechanics, waves, a little bit of electricity and magnetism. So it's kind of like that introductory course to physics that if you go to college, you'll be glad you took.
And then
Okay.
AP Physics 1?
AP Physics 1 is actually a college level course. We also have it with the Ccp Physics. Again, it's Physics 1. It's covering those same topics that we do in regular Physics 1, but it's at a college level. So there's further applications, there's more challenging problems, there's more in-depth concepts. It's the same material, but it would be very similar to what you would do in a first-year physics college class.
And then the step up from that is AP Physics 2, correct?
Right. That basically covers the second half of physics, the topics that we don't cover in Physics 1. So it starts with fluids and thermodynamics, then we do a major section on electricity and magnetism, which is quite in depth. Then we go into nuclear physics. We also do light and lenses and optics. So it's covering all those topics that we didn't quite do in Physics 1, because it's a huge course.
You did not plan on becoming a physics teacher, so what inspired you to be a physics teacher?
Well, I'd always thought about being a teacher, and I was originally an engineer, and I didn't feel like I was getting what I wanted out of that career. So I decided to try teaching, and of course, just going from engineering, I had a physics degree already, so I thought that would be kind of the natural thing, is to teach physics. And I love teaching physics because it's applied problem solving. You know, it involves math. I love math too. I also teach math, but being able to take that math and actually see where it's used to apply it. Physics is everywhere, okay? And that's why I like to teach the class and tell my students to look for it everywhere, because you see it in your everyday activities. So it's just something that even if you're not real strong in math, you can really appreciate the concepts of it and thinking about it. I feel like that kind of empowers you and makes you look at the world with more interest. So for me to be able to do that, you know, for high school students is kind of like the best job I could ever want to do.
And that leads into my next question. How have you seen that like positively affect students, like teaching physics and seeing them, you know, be enlightened, so to speak?
Well, it's fun to watch the difference between the beginning of the year when kids are kind of just sort of staring to the end where they're actually coming up and saying like, hey, well, I was on driving in my car the other day, and when I was turning, and it kind of makes you think about things. Going to the amusement park becomes a whole new experience when you're on like a Ferris wheel or a merry-go-round or a roller coaster, and you kind of understand why your body's being flung this way and that. So for me, that's just really gratifying, and I'm hoping, again, like students realize that physics isn't this really intimidating science class that they have to be scared of, but really something to really be enjoyed.
It's rewarding. It's an everyday life.
Exactly.
Ms. Burd, how hands-on is physics?
Well, it's very hands-on. In fact, if you would like to put your hand on there, I will give you a static charge. This is our Graaff Generator, which is one of the students' favorite demonstrations because right now you're getting a static charge on you, and I don't know if you can feel it, feel the electric field. We can hear the static, all right? And that, yeah, you'll start to feel the hair stand on end on your arms and legs, and even maybe on your head. So right now, if you take your hand off, you actually are charged. So if you were to touch somebody, you'd give them a little shock. All right, oh, here comes a willing volunteer. Oh, okay. And then, here, I'll show you. If we don't put your hand on it this time, I'll just crank it up and just show you. This is quite powerful, right? Okay, so you, yeah, you kind of feel, that's the electric field that you're feeling. So it's invisible, but
Yeah.
you can feel it.
So
So
physics is definitely hands-on because some of the stuff is not necessarily tangible. You have to kind of,
yeah, you actually have to see it, right? And
Yeah.
that's what I really enjoy doing demonstrations with the students. I think that's really one of the fun parts of class, something that we really look forward to. And I have, you know, all sorts of different ones. You know, we racing balls down ramps. You know, we do a sound lab with tuning forks, which is really enjoyable. Just, you know, all kinds of things. This one's kind of fun. We do study electricity at the end of the year. Sometimes it's kind of fun to get that out in the middle, just because in winter is when it really works well. It's really dry, lots of static. So, but that's certainly an important part. I think is the students understand things a lot better once they are, you know,
doing it themselves,
doing it,
experiencing
right?
Seeing it.
Exactly. Okay.
So, Ms. Burd, my last question for you is, how worth it is physics? Can you show me?
Well, it's definitely worth it. See?
That's how worth it is.